All right, so this is chapter 9, section 7, similarity transformations. Our learning objective by the end of our short session is going to be to identify similarity transformations and to verify properties of similarity. All right, so let's take a look at problem number 1. Triangle LMN has the vertices -4, -2, -3, -3, and -1, 1. Suppose a triangle is translated 4 units right, and I'm going to highlight that because, and 2 units up. Then dilated by a scale factor of 0.5. The center of dilation at the origin, which makes our life easier because you can just straight up multiply it by 0.5. Sketch the resulting image of the composition of transformations. So the first thing that we're going to do is we're going to find our first translation, which is 4 units right and 2 units up. So I'm going to, on my graph, I'm going to put the original image. So this is L. M is -3, -3. N is -1, 1. Okay, so we're going to do the first translation where we go 4 units right. So we're going to add 4 to each of the x coordinates. And we're going to add 2 to each of the y coordinates. So when we do that, we get L prime is at 0, 4. So our first translation takes us here. M prime is at 1, -1. And N prime is at 3, 3. So we moved it over 4 and up 2. All right, so the next thing we're going to do is we're going to shrink this down by half. So we're going to take each of our coordinates and multiply the x and the y by 0.5. So you go 0 times 0.5 is 0, and 4 times 0.5 is 2. 1 times 0.5 is 0.5. And -1 times 0.5 is -0.5. Lastly, 3 times 0.5 is 1.5. 3 times 0.5 is 1.5. So it's going to shrink this down. And we're going to have an L double prime at 0, 2. So this is the final resting place of our image. M double prime of 0.5 and -0.5. And N double prime at 1.5, 1.5. So this little blue triangle here is our squished down version. All right, so let's look at problem number 2. What is a composition of a rigid motions and a dilation that maps trapezoid ABCD, this one, to trapezoid MNHP? So if we look at the coordinates of our pre-image, A is at -6, 2, B is at -2, 2, C is at -1, -2, and D is at -8, -2. And compare them to our image. M is at 3, or 3, 1. N is at 1, 1. H is at 0.5, -1. And P is at -1, or 4, -1. All right, so it looks like we're going to have to reflect our ABCD across the y-axis, because if you look, AD has the same angles as MP. In order to get it on the completely opposite side, we're going to have to reflect. And then once we have it reflected, we're going to have to shrink it down because he is smaller. So if you look at our coordinates here, we'll just start here. We go from -8 to +4, from -2 to -1. The relationship between each of our coordinates from our pre-image to our image is that we have a dilation of a factor of 0.5. So our key concept is two figures are similar if and only if there's a similarity transformation that maps one figure onto the other. So if you can't come up with a similarity transformation to map one onto the other, then it is not similar. So question number 3 says, is there a similarity transformation that maps triangle JKL to triangle RST? If so, identify the similarity transformation and write a similarity statement. If not, explain. So what I did is I grabbed this triangle RST and I said, well, if you look, the long side here is JL and the long side of our RST is side RT. So I want to line JL up with RT so that you can actually see how they're which angles are supposed to be related with what and which sides are supposed to be related to what. And if it bothers you, we can draw these right side up. So now I can see RST, the bottom side RT corresponds with LJ. So corresponding sides of figures are proportional for similar figures. And so we need to set up a proportion to tell if it's a similar figure. So we're going to go, the first one I'm going to set up is JL and how it relates to TR. So JL, hold on. We decided last time that we were going to have it's image over pre-image. I'm going to keep that pattern. So our image is TR over JL. So TR was 20 and JL was 16. If I reduce that down, I divide by 4, I get 5 over 4. I'm going to do the same thing with RS and KL. So RS over KL is equal to 12 over 12. It's equal to 1 over 1. Is equal to 1. And then the last one, I don't have to do the last one, but I'm going to, is TS over JK. And that's 16 over 10. Which if I divide by 2, I get 8/5. So if you look, 5/4, 1, and 8/5, none of these are equal. So this is not similar, since none of the proportions of the corresponding sides are equal. Boom. And that's the end and the beginning of that.